No, follows me. So here's our free body diagram, right? This is number 2 that we've got now. Okay? And in part A, I'm guessing they want to know what does F need to be if the box is going to move at constant speed, right? So if the box is moving at constant speed, what does that tell us again right away? Right, acceleration is 0. So we know right away that if it's moving at constant speed, the acceleration has to be equal to 0. Okay, so anytime we got a free body diagram, we start with Newton's second law, right? The sum of the forces equals ma, the net force equals ma. All right, so let's do exactly what you did for the simulation. What did you do if you had things moving in opposite directions, the forces in opposite directions? What did you do? You subtracted them, right? That's all you did. Okay? So don't think too hard. If you've got things in opposite directions, you guys subtracted them. People pulling in opposite directions. So we've got 10 minus F, correct? Make sense? Okay? And that's equal then to our mass of 6 times 0. So if we're going to have an acceleration equal to 0, so it's going to move at constant velocity, we need F to equal 10. Good? Okay? So let's think about this. You told me in the previous problem that if we're going to have the object not accelerate, right, in problem number 1, part A, right, if you wanted to not accelerate, then that F had to be equal to 0, right? So the whole force acting on it had to equal 0. So if we want the same thing to happen here, this force needs to be balanced out by that force, correct? Does that make sense? So that the net force, the total force, was equal to 0. There's no leftover force. Because think of net force as the leftover force. Okay? So let's look at part B. Part B then asks, what is F if we need an acceleration of negative 1.5? All right. So again, we start with Newton's second law, right? The net force is equal to ma. Okay. Now, if we look at what we've got here, has this changed at all? Has this situation changed at all? Right? Maybe this F is different, but in terms of the forces that this box is experiencing, it's all the same. Right? Okay? So, again, all we're doing is opposite directions. We're just going to subtract them from each other. So we got 10 minus F equals now m is 6 and 1.5, negative 1.5 is our acceleration because they give that to us. Okay? So now all our job is to solve for F. Okay? So 10 minus F, 6 times 1.5, negative 1.5 should give you negative 9, I believe. Does that make sense? Yeah? Negative 9? Okay. So now if we do this, if we add the F over here and we add the 9 over there, we find that F has to equal 19 newtons. Okay. So if we stop again and think about this, okay, the negative 1.5, we want it to accelerate at negative 1.5 meters per second squared. This is the negative direction, right? If we think of our XY axis, right? To the left would be negative, right? And to the down would be down would be negative, okay? So that means we want it to accelerate in this negative direction. So does F have to be greater than 10 to get it to accelerate this way? Right? If you want something to accelerate in that direction, you got to pull hard in that direction, right? Or harder than anything going the other way. Make sense? Okay. All right, so let's try part C. Now they want to know what is acceleration, what does F have to be if the acceleration is going to be 1.5? So we keep that force, all right? So Newton's second law, we're still going to subtract them because they're in opposite directions, right? They're going this way, okay? We know our m is still 6 and our a now is 1.5. All right, so that's then 10 minus F is equal to positive 9, or F has to equal 1 Newton. So if we look back again at our free body diagram, now they want it to accelerate this way in the positive direction. So if we want it to be in the positive direction, does this need to be the greater force? It needs to be the greater force, right? If we want it to go in that direction. Okay? So those are like little quick things just to check your math and make sure that your number makes sense, because we want them to go right we want the net force, the leftover force, to be in the same direction as the acceleration. Okay? And we saw that actually, on Friday when we did that other exercise. We saw the net force and the acceleration are always in the same direction. Okay? What if I had, this isn't on there, but what if I had another force that was like 2 this way? Maybe this was someone pulling, and maybe this was like a little, maybe like a little motor pushing the box along with applying 2 Newton force. How would we change this equation right here? What would you do? Instead of 10 minus F, what would you do? What do you think? Add a what? Well, we've already got the 10, so just... No, we've already got the 10, so we would just add the 2, right? We just add the 2, because we've got now, and remember, anything going same direction we're going to add, right? And if we had like a 3 going this way, we would have to then F minus 3, and we just sum it all up. Does that make sense? Okay? Pretty simple, not too bad? Good? Any questions? All right.